Hi, my name's Maureen. Let's do an optimization problem together. So this one has a parabola with a rectangle inscribed inside of it. Okay, so I drew a picture, which is always a good idea, so you have an idea of what you're working with. We want to maximize the area of the rectangle. So the area of a rectangle is base times height. So I'm showing there that the two x's will be the boundaries of the base, so that the entire base is 2x. And the height of the rectangle will be the location where we hit this point on the parabola, the y value of the parabola. Okay, so our area equation will be the base, which is 2x, times the height, which is the 7 minus x squared. Okay. And since we have to take the derivative, if we left it like this, we would need the product rule. So I would simplify it a little bit so that I can just use the power rule, which will be easier to take the derivative. So 14x minus 2x cubed. Right? So we have our equation that we want to maximize. Once you have that equation, you take the derivative. So a prime is equal to 14 minus, so the power comes to the front and multiplies that 2, right? So we get 6, reduce the power by 1, so it's 6x squared minus 6x squared. So pretty easy derivative there. Now, maximum and minimum problems always have this next step in them. You set the derivative equal to 0 because you're looking for a location where your function has a horizontal tangent. So we're going to take our derivative equation, 14 minus 6x squared, set it equal to 0, and solve that. Okay. So we get 6x squared is equal to 14, and x squared is 14 over 6. So x would be the square root of 14 over 6. And this would be a calculator problem. This is obviously not one that you would do by hand or mental math. So it would be, I did a calculator estimate of it, and it's 1.528. Okay, so this is 1.528. That's our x value. Now once you've done that step, you always want to go back to the problem and see what they asked you for. And this problem asked us for the dimensions of the rectangle, which means we need the base, which is 2 times x, and the y value. So if we take 2 times x, the base ends up being 3.055. Okay, and the height, I substitute the x value back into the equation. So I put back in 7 minus x squared. So let's just use 14 over 6 there because x was the square root. So if I square it, I'm just going to get 14 over 6. And that comes out to be 4.667. 4.667. So my dimensions are 3.055 by 4.667. Okay, units. Let's see if they had units in this problem. They did not. They did not use units, so you wouldn't be able to give units. But of course, if units were in the problem, you would want to finish up with some units on that as well. I hope this was helpful, and hope to see you on a Wyzant site, and maybe we can help you with another problem. Thanks.